Okay, in our next section, dealing with trigonometry, we're going to be, as you can see, measuring the angle of a given, determine the measure of an angle that's given, and solve real-world problems using trigonometry. So if we go back and think about really what happened, in our first section, we were given the angle measures, and you found edge lengths, the sine, the cosine, the tangent. Some of them were nice whole combinations. Some of them were radicals, as we found out. But we were using our sine, cosine, tangent to come up with those. This case, though, we're going to be given the edge lengths, and you'll have to find the angles. So, in this situation, I've just given you a scenario, and we will draw a picture, do the math, whatever it takes to get our missing angles. So now we know these are right triangle trigs, so that's the one advantage we have going in. We know we have a right triangle. So draw your 5, 12, 13 triangle, and we will find the missing angles. All right, if we drew, it's not going to be totally to scale, but if you got your ruler out, you could do that. Here's probably a good approximation of a 5, 12, 13. Remember, 13 is your longest edge. It has to be opposite the right angle because that is the largest angle. So we know we have a 90, and they didn't give us any labels, so we're just going to go with our own A, B, C. So right now, we know angle B equals 90. It's the other two that we don't know, and so we're going to have to find them. So let's, I'll go back and find angle A first. Okay, so angle A. If we came down here and said angle A is our reference angle, we could use any of the edges. We could truly use sine, cosine, or tangent because we have all the edges. But just pick one. It does not matter. Some people like sine always. Some people like tangent always. But you have to go with it. Sine of angle A, which we don't know, A is our variable in this case, has to be the opposite over the hypotenuse. We know the opposite edge is the 12. We know the hypotenuse is 13. Now, you could, with the help of your calculator, probably divide out 12 divided by 13 and get a messy decimal. But what you have to remember is that we can undo anything in an equation. So here we have the sine of an angle. Well, if we would do the inverse of sine, the inverse of anything undoes it, on both sides of our equation, that would undo the idea of sine, and the sines would cancel, but that would leave us with A. Well, that's exactly what we want. We want the value. So now watch what happens. On your calculator, you have your sine, cosine, and tangent keys, and immediately above them, you have sine to the -1, cosine to the -1, tangent to the -1. If you would now use those, we would be able to find our angle A. So, with that, make sure, one other thing before you start, make sure your calculator is in degree mode, which means go to your mode key, go down 3 spaces, and make sure it says degree, because our triangles right now are in degree, and we want everything to come out and not be weird, only because we have our calculations in the wrong mode. So we are now in degree mode, and we would do exactly what it says. So we would do second sine, and we put our 12 divided by 13 in parentheses. We close our parentheses, we hit equals, and it's telling us that it's approximately a 67.38-ish, but we're going to go for whole numbers right now, and we'll tell you otherwise. So it's a 67.38-ish, so we'll go with 67 degrees is our angle measure for angle A. So now angle C, easy enough. You add the two you have, or know that one of them is 90, the other two have to add up to 90, and you could get 23 without having to do another trig function. So 67 and 23 is 90. We already had our right angle. Done. Easy way. So we had to do one trig function. Now, what I want to remind you of, when you hit sine, cosine, or tangent, you were finding, change colors, edge lengths, proportions, edge ratio, okay, or the ratio of the edges. But now if you're using inverse of sine, inverse of cosine, and inverse of tangent buttons, you are finding degree of an angle. So be careful and make sure you realize which situation you're in before you go and just start punching keys, because it's the calculator. It'll give me the right answer every time anyway. Not always the case. Our next example, they're going to talk about real life problems, and they're going to say, well, your angle of depression equals your angle of elevation, your angle of elevation equals your angle of depression. True statement, but you have to realize where they're at. This should look really, back from geometry, like two parallel lines cut by a transversal. And when you do that, you're talking about angle of elevation, angle of depression. And if we say you are the person, and let's just say this bottom horizontal line is ground level, these two always happen from the horizontal. So angle of elevation, if we made this the angle of elevation, so we're here, we're looking up. Whoops, didn't want to do that. We're here, we're looking up. This angle going from here to here is what we're talking about, the angle of elevation. So there and looking up towards the sky, that would leave us the angle of depression because of transversals, alternate interior angles. That would leave us with this angle from the horizontal to be our angle of depression. And because there are alternate sides of the line, we learn alternate interior angles are congruent. Those are angle of depression, angle of elevation. Okay? And you will use those in your work. An angle of elevation and angle of depression are always equal. So that will be helpful in some of the real world problems that you're going to see in your homework today. So set it up. Think of it, two parallel lines cut by a transversal. Alternate interior angles are equal. Now, just to reset this for a second, somebody said, well, what if I would have chosen this as my angle of elevation, and I was looking up and I was going in this direction? Yeah, I'm with you. Okay, from the horizontal, you're looking up. Then this, alternate interior angles, would be your only choice. That would also be your angle of depression for that combination, and it would come from the horizontal. So alternate interior angles are equal, and you could have angle of elevation, angle of depression are equal. You will also be working on finding the angle of a regular polyhedron. Remember from geometry that you used a formula that says 180 times n minus 2 divided by n. And let's just do an easy one. If we had a quadrilateral, we know that that's 4 sides. Okay, it's an easy one. Just check your formula on. And so you've got 180. But if we have 4 sides, 4 minus 2 would give us a 2. Divided by 2. Oops, sorry, divided by 4, because that was our n value. And so now we've got 180 divided by 2. You can do some canceling, your choice, if you're doing it in your head. And we would end up with 90 degrees. 90 degrees is that angle of a regular polyhedron. So if we had a regular quadrilateral, which we should know is really a square, that's telling us that every angle in it is 90 degrees. And 90 times 4 is 360. So that formula is going to come in handy, especially when you get up into maybe things like 5, 6, 7, 8, 9, 10-sided objects, and you might not remember what the interior angles are. All right, so if we have a rectangular sheet of paper, so start thinking about your rectangular sheet of paper. We will draw and label it, and I would highly recommend you do that. It's 35 centimeters wide. it's cut diagonally. So there's the width of our paper. It's cut diagonally, so the acute angle opposite the 35 measures 28. So it's cut diagonally. So we're going to cut our paper diagonally, and it says the angle opposite the 35 centimeter width, so this one right here measures 28 degrees. So obviously if it's a rectangular piece of paper, that's your right angle. And so now, what is the length of the paper? So in other words, they're asking what's this, or what's this if you want to choose that triangle. They're both identical, so it really doesn't matter. So one thing we can do is start marking the triangle in terms of what we know, what we don't know. And we have already as we set it up, but we can do one more. This lower angle. If we have 28 here added to it would have to equal 90. So we're looking at what? 62 degrees. So we got 62 degrees, 28. Now if we know that, we can probably use our trig functions. And we don't know the cut that's diagonal, but we can work with just that x. That's all we need. So think about this. We got to have the x. The 62 looks good going with it. The 35 is the other edge we can use. So what is the x and the 35 either in relationship to the 28 or in relationship to the 62? There's a couple different ways you could set it up. If we go with 28, because that was the given value, if I look at 28, that's the opposite. That x value is the adjacent. That sounds like tangent to me. So if we did the tangent of 28 is equal to the opposite over the adjacent. The opposite over the adjacent would be 35 over the adjacent is x. Now be careful, because now you've got the tangent of 28 degrees, which is not one that you commonly know, but it's just a proportion here. So we can solve this, cross products. X times the tangent of 28 has to equal 35. We want to solve for x, so we're going to divide both sides by the tangent of 28. And we should have that x value. And they didn't say approximate or anything, so go ahead again, double check your calculator, make sure it's in the right mode, and you should be able to do 35 divided by the tangent of 28. And I got about a 65.8 for my edge. And it was in centimeters, so we'd have to say centimeters. So and that appears to be right if we're talking about a rectangular piece of paper that they described. If that width was 35, our length definitely has to be longer, and it truly is. Okay, good work there. Let's go to the next one, and we're actually on to our homework. So bring any questions you have to class, and do not forget that these tangent and cotangent values need to keep being worked on, and we will deal more with them, especially in our special right triangles in the future.